Hi and welcome here to the presentation about the mega trends that is impacting our societies, the legislation, and in the end the technology and the markets that we work in. My name is Jonas Hammann and I have here today with me Torben Funder Christensen, and Torben will take us through some of the mega trends that are impacting our societies today. So we have mega trends such as decarbonization, electrification, and urbanization. In fact, it's expected that about 70% of people will be living in cities by 2050. So Torben, talk to us a bit about this. How does it impact our industry?
Yeah, it's a big question, of course, you can say, because we are coming up from these high-level trends, and we try to drill down now and say, how is it affecting things? And some of the things we will see is, and it's already there and has been there for some time. Other things, they will be much more future-oriented, and it's basically only in the infancy of its development here. But we tried to do that by illustrating it with a triangle here, and we have some of the main trends here. You can say electrification, very technical oriented, of course. Digitalization also, which is much more about the tools, the opportunities you have really to fulfill your technical desires here. And then you have climate, of course, which is about avoiding CO2 emissions. On the other hand, you have what is happening with populations also and their needs. And here we have food, comfort and health, and we have also the urbanization, which covers most of the population growth. Inside the triangle, we have a lot of, you can say, even smaller and more precise trends here. We have waste heat recovery, which is high on the agenda at many governments right now, also in much legislation also. We can just mention the green recovery plans, the Green Deal. We are talking about cold chain versus food loss also. We have to avoid food loss simply to be able to feed people in the growing cities also, especially in the developing world. And by the same time, we will reduce CO2 emissions also. Simultaneous cooling and heating, we have to look at that also if we want to heat up the large cities and at the same time also have cooling in the cities. We should use both sides of the cooling cycle also. Thermal grids, super important here, because if you want to do simultaneous cooling and heating, we should be able to share these products of the vapor compression cycle also. And then we come also to more dedicated, you can say, issues here around real efficiency optimization. It's not enough only to say, I have an efficient equipment. You also need to really run your equipment efficiently. Food production, we see today that a lot of food production is becoming even more industrialized. One good example is fish production on land, for instance, where we will not, you can say, go to the sea and take the fish out of the sea anymore. What we are going to do is actually to produce the fish on land and avoid environmental, you can say, consequences of that. Demand side flexibility is about how to have a total energy grid, like more or less one organism, so that the demand side, which could be a vapor compression system, basically talks together with the electricity suppliers, which will be based on wind energy. So the fluctuating systems, they can be balanced by us having the vapor compression systems ramping up and down in these systems.
Okay, that sounds very interesting, and a lot of different things that are moving around. So are there any way, or how can we rank them? How can we look at them? Can you explain a bit more about that?
Yeah, I can, because there are some dilemmas here also and some paradox. I think we would like to take a look at this technology maturity, because first of all, MEPS is minimum efficiency performance standards. That has been around for 50 years or even more. Low GWP refrigerants means low global warming potential refrigerants. These refrigerants, we have talked about them for the last 25 years. So somehow technology maturity around these things is relatively high, there is a limit to how far we can go on system efficiency also. There are thermodynamic limits we have to observe. On the low GWP refrigerants, well, still there is something to gain here also, but we are somehow quite confident that we will go with low GWP solutions somehow, and the legislation is also settled around that. If we then look at some of the very high potentials, then we are looking much more into some of the things I just talked about, the waste heat recovery. Suddenly we are improving the real efficiency of systems by a factor of 2. We do that by doing the same simultaneous cooling and heating, you can say. For doing that, we need the thermal grids to share capacity, and we can also, by the thermal grids, actually have a very, very cheap storage also. That fits super good together with the demand side flexibility, which again means also you have a request from electricity suppliers. You can ramp up and down on your electricity consumption by utilizing all these factors here also. Outside that, then we had the cold chain versus food loss, which has a tremendous potential for reducing CO2 emissions. So we have to, you can say, increase the amount of cold chains in the world, but we have to do it in a smart way and with, for instance, of course, low GWP refrigerants also. The other thing is that we need to do this also in a way that is affordable for people. Yeah? So we need to look at the online efficiency optimization, which ensures you that when you buy a system, that you're actually also running it high efficiently. Yeah? And then, of course, also the food production, which has a lot to do with the cold chain and food loss. Well, we need to simply develop this business area, you can say, by having much more environmental control, and we need to optimize then based on this environmental control, the food production, which could, for instance, be fish, or it could also be greenhouse stuff, vegetables, and so in proximity to the big cities.
Okay, that's very interesting. And so what I hear you saying is also that we are moving more and more away from minimum energy performance standards and low GWP refrigerants, even though it's been in the industry for many years and there's been a lot of energy and still are being put a lot of energy into this area. We are moving away.
I still think that we utilize 80% of all our resources and capacity in optimizing these things, but they are also quite settled in their concept, you can say, but still that they will never go away. You will still have to work with these things, yeah. But this is the really, you can call it, the sustainability potential boosters, yeah.
Okay.
Yeah.
Okay. So let's try to look a bit ahead on the refrigerant specifically. What are the trends that we are seeing here, and how is the legislation impacting it?
Yeah. On the refrigerant side, we have quite good legislative frames now. We have in the EU, we have the European F-gas regulation, which ensures that you will have a phase down of the refrigerant consumption during the years, so you will reach around a 20% of the consumption in 2011 by the year 2030. And then we also have now the amendment, or since 2016 we have the amendment to the Montreal Protocol, which ensures that the rest of the countries in the world, they will also phase down their consumption of HFCs, yeah, in the way that the HFCs, they do the emissions, yeah. So again, it's built up on the developing countries and then on developing countries, yeah. So all these things here, they imply, for instance, the acceptance of flammable refrigerants. Could be natural refrigerants, could also be synthetic refrigerants, but we will have to accept the fact that they are going to be flammable in many applications here also. And then, of course, you can ask yourself, is that only done with natural refrigerants, or can we also do that with synthetic refrigerants? We also believe we can do that actually, but there will be some targets of global warming potential values, which for instance could be 150. Interesting and challenging target, I would say.
Yeah. Yeah. I know that we made also this slide to sort of explain that trend. So can you try and take us through the slide?
Yeah, what we did is actually we have of course we have monthly meetings on these things, and we made this slide here where we have GWP values on the one axis here, then we have the type or the families of refrigerants on the x-axis where you are moving up in pressures here, and then we have the old well-known main refrigerants in each group here, starting with R134A, R22, R44A, and R410A. And these refrigerants, they have to be substituted. This one is special because it's already now under phase out, not only phase down, but phase out, yeah. But anyhow, we need to have candidates there, and likely you will have to leapfrog, because what we did in developed countries is to go from R22 to these ones here. Now we need to leapfrog into something down here, yeah, in the developing countries. That is the wish picture, you can say. So what we see here is a flammability line, yeah, and that has really been the reason for many concerns. Because if you move down below this line here, then you're moving into an area where refrigerants, they basically become more and more flammable. And you have to take notice of that, because we are living in a world that got used to refrigerants that were not flammable. So we need to develop the right standards, we need to educate people, it needs to be a kind of born-in measure in the market. Yeah.
Okay. And so when we look at this, then we can say that we are moving in a similar direction. You could almost say, yeah, like maybe leading by some regions in the world. But how is it that they are now, coming together when we look at it from a refrigerant perspective?
Yeah, that's it's actually an interesting question, because we have been in that game here for 20 years or so with the phase down things, and we have a headquarter based in Denmark. Denmark was one of the first countries that made a legislation saying we will not have HFCs. But then they made some exceptions also where you could still use that. So it really forced us to look into alternatives. We did that at a very, very early stage also. We looked at very low GWP refrigerants. They were not viable because they were simply in the beginning. It was very expensive, and that was not very efficient either. Yeah? But it's always so that when you concentrate, when you put your resources into that, and you see universities starts working with that also, then system starts to develop, technology develops, you get wiser simply. And then it moves into a viability area, so it becomes sustainable and viable. Yeah? The other thing we saw in many other countries is, well, let's try and take existing applications. Let's try to drop in a refrigerant that is very much like the old one, but has a lower GWP value. So you came from a high GWP area and moved up here by adding low GWP refrigerants here also. So that's actually also where we see the convergence of new and older technologies. Well, the low GWP applications, for instance, good example is CO2 in supermarkets. They become very efficient and affordable also. And we saw also that high GWP applications, they adapted to lower GWP applications. We have seen that actually in air conditioning systems also.
Okay. Okay, so you teased a bit for it in the beginning that there are other trends now coming in and impacting our industry. So let's take a look at the decarbonization and some of the trends that are happening under that umbrella.
Yeah. Yes, because decarbonization means that we should somehow not stop using electricity, but we should at least stop using electricity that is based on fossil fuel-based, you can say, power plants. So, well, coming back to vapor compression, refrigeration and air conditioning, heat pumps also, of course, then it takes around 20% of all electricity in the world. That is a very high number, and people, they normally are not reflecting on that. So it will not go away, of course not, and we need it because we need comfort, we need to have healthy food also, and we need to at the end also have decarbonized heating also. So the big numbers here, 20% today. We know that factor 3 of rise in air conditioning in developing countries also, and we also know these numbers are from India, around a factor 3.5 in the rise of cold chain only in one country also here. So tremendous need, tremendous challenging if you want to decarbonize, and that's where it comes in that actual energy efficiency really matters, yeah, because it's not enough that your system is efficient based on a label. It has to operate efficiently also. So we need to look at standards, optimization of system efficiency also. So that's things that are ongoing also and will be increased also. The other leg here is really the decarbonized energy, because you cannot just take a system as it is and then say now you can use decarbonized energy. Well, you may do that, but somebody has to compensate that, because decarbonized energy also means a very volatile energy supply. Again, it means that we should be able to ramp up and down in our electricity consumption. And you do that by adding thermal storage, and it's much easier done if you have the digital tools to do that actually also.
Okay, so let's try and talk a bit more about these digital tools.
Digital tools actually they can be, for instance, very very simple measures like transmitters. It can be just communication also, but you have to equip your system with more tools simply to be able to measure the real energy efficiency. You also need to be able to communicate, to have weather forecasts. You can basically plan your energy consumption based on that also. And you need to have a kind of very fast signal processing coming from the electricity suppliers also to the end users, so that you can react very fast in ramping up and down in your consumption. And everything is basically supported by digitalization in that sense. Online efficiency, measures to uplift energy efficiency. If we look, I think I said in the beginning also that there is a limit to energy efficiency in the normal way we think about it. And we now have just taken this curve here from the US also and looking at how the SEER ratings were increased during the years. Of course, there are thermodynamic limits to how far you can go, but before you reach that limit, you have to look at the cost of your system also. Just imagine that, of course, you could be extremely efficient by doubling up your surface area of your heat exchangers. We knew that, and we developed, for instance, a new series of micro-channel heat exchangers, which was really addressing that issue. Yeah? But at the end, there is a limit to that. So the cost will explode, yeah, compared to the, you can say, the laboratory efficiency. So again, we say here, laboratory ratings, they only partly reflect reality here. And affordability here means a lot when we are developing maps. Maybe it would actually be a much better trade-off also to say, we also have to look at the real efficiency in the field, put demands up on the, and by digital means, being able to measure online efficiency also. That, by the way, would then also address the bad behavior of using the systems. Sometimes systems, they are bought too small or maybe even oversized, and that would also again be very well reflected in the actual efficiency here also. They can be installed in a wrong way also, and they can be maintained very poorly also. You have to clean, for instance, your condenser from time to time. Otherwise, efficiency will just degrade.
Yeah. Okay, and how are we as Danfoss then working with these trends if we try to take it all together, and how are we engaging with our customers and working with these trends? Yeah,
it's something that started 10-15 years ago where we said it's simply necessary that we start building up large laboratories that are able to take in the applications. Systems, we have to take in our customer's system and we optimize them. And we learn and we understand how they function under different conditions. So we said, this is not only a headquarter issue. This is actually something that we have to do globally, simply to adapt to the global needs around these things. Because our customers, they are global, they are everywhere. Yeah? So what we said was, of course, this is our outset, came from our headquarters. But today, our biggest laboratories are actually placed in China, India, and in the US. And that is just a really strength for us, yeah. And we enjoy simply developing the application, our understanding also, and at the end it feeds back to product development.
Yeah. So if you want to leave the listeners here and the spectators with some last remarks, what would that be?
Yeah, just to sum up, I can say that the standards we have today on efficiency and the low GWP refrigerants, they are simply necessary. We have to continue with that also. But in the horizon, we now see already the new type of application developing, especially addressing climate change, food, health. And that is a huge opportunity for us, for the total industry, to follow these things also. And I think that is more or less capturing the last 2 points here. But I think our industry, vapor compression, has so much to offer to a future modern, sustainable world.
That's very good. That's very good to hear. So I would encourage everyone to reach out to one of our colleagues, and then I want to thank you for listening and watching, and enjoy the conference.